StreamStory is a tool which is intended to help with analysis and interpretation of time-varying data. The system helps the user search for recurrent patterns by representing the data as a diagram of states and transitions, where recurrent patterns visually stand out. To construct its representation, StreamStory uses and adapts several machine learning techniques. The StreamStory's mechanisms to uncover and explain the structure within the data are visual and textual and are explaining states and patterns within the data. StreamStory uses sparse feature vectors as its input. The Buy4You analytical platform allows user to export public procurement data as a sparse feature vectors which are stored in CSV file. This file can then be imported into the StreamStory. The system expects the columns of the CSV file to be named in the first line of the file and that one attribute is a numerical representation of time, which can be any millisecond time representation. Please note that input data are not stored on the StreamStory server and are used for computing the model only. Public procurement data could be exported from our web analytical platform. On our web analytical platform, we first select Streams and then click on the button Get Feature Vectors. We can select public procurement data according to buyers, bidders, or both. For buyers, we can select buyer groups, for instance, schools, hospitals, and so on. By clicking the button Get Data, Web Analytical Platform generates CSV file. This file will now be imported into the StreamStory tool. First, we need to log in. If we do not have username and password, we can register for free. When we are logged in, we can add a model. First, we select a CSV file, and when the file is read, we select which attributes we will use in our model. In our example, we will use a date of notice, which is a date of public procurement publishing, procurement category, which could be goods, services, or construction, procedure type, which indicates the criteria for selection of buyer, a variable indicating whether tender has been published in EU, number of received bids, and the final value of the contract. Now we need to select which attribute is time attribute. In our case, it is date of notice, and for time unit we will select a month, since for public procurement data, day or month is the most suitable. Then we should define attribute types, which could be numeric or categorical. We also select that we would like to include derivative information to the feature vectors, since this helps to reduce ambiguities in recurrences. We can also set some other more technical parameters, like which algorithm to use to construct the partition, number of states and hierarchy type, and so on. But typically, default values should be used. Finally, we can enter the name and description of the model, and the model could be built. The main view is presenting identified states in the time data. First, we will zoom in to get a feeling what could be the most explanatory number of states, since we do not like to have too simple or too complicated model. In the main view, we can see the most prevalent states, and by clicking into them, we can also get their properties. We can also rearrange the identified states to get a more clear picture of the data structure. By clicking on Options, we can select which attribute will be used for recoloring the model. Recoloring mechanisms help us to uncover particularly interesting states. In our example, we are looking at the bids received by 7 biggest Slovenian IT companies. We have selected those IT companies which had closed the biggest contracts with Slovenian Ministry of Public Administration. Here we can see states with the highest number of bids and states with the biggest final value of the contract. When selecting the state with the highest number of bids, we can see that this state has in average received 378 number of bids, with the average final value of contract more than 440,000 euros. From this point, the system goes to two states. One has in average 1.3 received bids and the other has in average 2.7 received bids. In both states, the final value of the contract is around 100,000 euros. This clearly shows that system tends to go from states with higher number of received bids to states with lower number of received bids. By our opinion, this is an indicator of a vendor lock-in. If we select the state with the biggest final value of the contract, in average it is 2.8 million euros, we can see that bids in this state are always published in EU and the average number of received bid is 2.4. This state always goes to state with 1.5 number of received bids on average and final value of the contract around 300,000 in average. In that state, only 83% of the bids are published in EU. From this state, system always goes to the most prevalent state with 2.7 number of received bids, the final value of the contract around 100,000 euros, and where only 80% of the bids is published in EU. This also shows that the system tends to go from higher to the lower number of bids, which is also an indicator of vendor lock-in. StreamStory tool is available at website streamstory.ijs.si. The source code is available in JSI GitHub repository.